Okay, so like I was telling you earlier, this has increased by a factor of 4. So this simply tells that the rate is increasing as a square of the concentration. Since the concentration increased by a factor of 2, 2 squared is 4, that has increased by a factor of 4. So these are some of the, or a method you are going to be using when you are doing your analysis. You are explaining without calculating. You just tell them when the concentration was doubled, the rate tripled, quadrupled, or the rate increased by a factor of 4. This simply means that the rate was increasing as a square of the reactants. This kind of a behavior is a second order behavior. Therefore, the rate with respect to A is second order. That is how you're going to be explaining when they ask you to tell us the order of the reaction without calculations. I don't know if it is this year, last year, or some other year, but there was a year in a tutorial sheet they specified like that. And I think even in a test, if not the exam, they also specified just like that. Tell without calculating the overall order of this particular reaction. So this is why you're going to do it by observation. So you should give yourself practice. Try to use both methods. This method of calculating is simple, straightforward, because it just gives you numbers that you can use. But the observation method can also be asked. So you have to be equipped for both when the question comes. So for example, this is another example. You have 3 reactants, A, B, C, D, I mean A, B, and C, giving you D and that. So I will explain using the observation. You guys take screenshot of this particular part. You are going to answer using calculations. So me, I will explain to you using observation. And then you're going to confirm the orders I will give you using calculations for the practice. So take a screenshot. So what it is here is this: experiments 1, 2, 3, and 4. So what I'm going to do is I'm going to pick 2 experiments in which 2 of the reactants are kept constant, and then only 1 reactant is changing. So I check experiment 1 for A, I have that value, I have this value for B, I have that value for C. I come to B, I have this, I have that, I have that. So all these are different concentrations. So I can't pick this one. I have this, I have that, and I have that. So this simply means I can use experiment 1 and experiment 3, because if you look at experiment, you have 0.2, and here you have 0.2. When you come there, you have 0.2, and there you have 0.2. So experiment 1 and 2 are the 2 experiments I'm going to use to find the order of the reaction with respect to B, because B is changing in these two experiments. Now, since L and B I'm not considering, so I'm looking at 2.4 and 2.4. Okay, you have 2.4 and you have 2.4. You add 0.2 and 0.3, but the rate has not changed. It is still 2.4 and 2.4. Since the rate has not changed even after changing the concentration of B, this simply means that this particular reaction with respect to B is 0 order. So I've already established that 0 is what? 0 order. Why? There was no change in the concentration. Since there is no change in the concentration, I mean in the rate, since there is no rate there is no change in the concentration, even after changing the concentration of B, this simply means that B had no effect on the rate. So with B, with respect to B, this is 0 order. I've established that. Once I establish that, I even eliminate B from looking at it as a factor that is going to affect the rate of the reaction. So I can now focus on any other 2 experiments in which say A is kept constant and only C is changing. So experiment 1 and experiment 4. In experiment 1, A is 0.2, and in experiment 4, A is 0.2. But in experiment C, it is 0.2 and 0.6. So since the concentration of C has changed, I will pick these and use them to find the order with respect to C. So I have 2.4 here and I have 7.2 there. So if you check 0.3, I mean 0.2 and 0.6, there is a change by a factor of 3. So the concentration here is changing by a factor of 3. Then I check, is the rate changing by the same factor? So I just in my head or on a separate sheet of paper, multiply this by 3. If I multiply this by 3, 3 by 4 is 12, 2, 1, 3 by that is 6, plus 1 is 7, 7.4, meaning this rate has also changed by a factor of what? 3. Since when this was increased by a factor of 3, this also increases by a factor of 3. This is direct proportionality, meaning the rate with respect to C is what? First order. Why is it first order? When the concentration was increased by a factor of 3, the rate increased by a factor of 3. This simply means that the concentration is directly proportional to the rate of the reaction. And this is the behavior of a first order reaction. So I have explained without showing calculations and doing calculations why this is first order. So I'm now only remaining with finding with respect to A. So with respect to A, what you're going to do is 0.2, find where C is constant. So C is constant throughout here, and then check for A. So 1 and 2, A is changing, so C is constant. So I just look at this. This is changing by a factor of 2. 0.2, 0.4, the factor there is 2. I come to the rate, 2.4 and 9.6. So I check if I multiply this by 2, 2 by 4 is 8, and that will give me 4.8, which is not giving me this. So the second order tells me that when you double the rate of a reaction is proportional to the square of the concentration. So let me look at the square of the factor difference here. Since this is increasing by a factor of 2, the square of 2 is 4. That simply means that the rate should increase by a factor of 4. So I will multiply this by 4. 4 by 4, 16, 6 carry 1. 4 by 2, 8 plus 1, 9. So this has increased by a factor of 4. So you have doubled here, but this has increased by a factor of 4. This simply means that when this behavior is only possible if the reaction is what? Second order, because in second order, the reaction rate is directly proportional to the square of the concentration. So I have established this is second order, zero order, first order. So overall, this reaction still remains at third order because it will be 2 plus 0 plus 1. That gives you 3 for the overall order of this particular reaction. So I've not made any of these reactions and then start doing calculations. No, just by looking, I can tell and I can deduce the order of the reaction. So this is what I was saying. You should be in a position, whichever angle the question comes from, you should be in a position to answer. They ask you, answer using this method, you answer. If they've left the question general, they've not told you which method to use. You can choose whichever method is conversant with you, whichever method you feel is faster on your end. Because every time you write a test, an exam, a quiz and stuff, you are working against time. So you want to buy yourself time. Don't think one method is inferior to the other one just because it is quicker and faster. No. If you understand the method and you can bring out the meaning of the method, you can use that method to answer and you won't be penalized. You will be given full marks. That is what this is. So you yourselves, start gauging yourselves. Use this method to answer, use the other method to answer as well. Whichever method you'll be conversant with, if a question were to come in a test, use that particular method to answer as long as they've not specified. So I, for one, can easily find the answers just by looking at what is happening. And I can tell the order of the reaction just by doing that. So if I were to write a test or an exam, that's what I'm going to use to answer. I'm not going to start doing calculations. No, I make this the subject, I start finding and then finding factors. No, that's time wasting on my side. So it depends with you, which one works for you. So don't just say, no, Mr. Chota said is able to do L and B, B and C, C and D. So we also are going to do the same. And then you find it difficult for you to explain it, for it to have full marks, full meaning. You fail to explain it. Then you lose marks. So please go with what is going to work for you. Okay, so we are past this now. So that is how we were finding those order of reaction. Now we go to looking at the integrated rate law. So we were looking at just the rate law, which is a differential. Now we look at the integrated rate law. So for the integrated rate law, if you check the law we are from doing, this is the rate. Rate is equals to K, A, and B. So since the rate is equals to K, A, and B, if you look at this rate does not contain the factor of time. There is no time variable here. But when you start studying the rate and you bring in the time variable, once you bring in the time variable, what you are supposed to use is the integrated rate law to understand that particular rate. So this is what is happening here. When we start looking at the integrated rate law, we are going to bring in the factor of time. So here, the equation that relates concentration and time is the integrated rate equation. So this is what it is. And we can also use this to calculate half-life of a particular reaction. So how long will it take for the concentration to drop by half and stuff? So we're going to look at that in this particular segment. Now, if I start this particular segment, we will not finish before our time elapses. So this simply means that tomorrow we will begin from here. We look at the integrated rate laws. And then from here, we look at how temperature affects the rate of the reaction. That will be done tomorrow. So this part and the temperature part where we have to look at activation energy and stuff will be done tomorrow. After that, Saturday, we are going to start revising, or we're going to start answering questions. And Sunday, we will be answering questions, meaning by Monday, we should have finished this particular topic and we should start talking about a new topic for the study. Is that clear?
Yes, sir.
Any questions on what we've covered so far? Okay, you guys do not have questions for me, but me, I'm a very fair person. I do fair play. So for me to be fair on myself, not on you guys, but on myself, what I'm going to do is not this. What do I want? Where is that paper? Where is that paper? Thank you. Okay, so I'm going to leave you aside from that question where you have to carry out the calculations and then tell what answers I gave you, whether they are right or not. I'm going to leave you with another question, which is just on what we've done today, not what we covered yesterday, just what we have done today, thoroughly just on that, so that you can practice nicely. So the initial rate, blah, 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 rate is supposed to be this and that. What is the value of this and this and this? So these are simple, straightforward questions, actually. That one doesn't have it again. How my mind. This is O3. Is O12 paper. I should have an O12 paper, which is straightforward, which has exactly the, it even has the table that I want actually. Maybe you guys are lucky today. I'm unable to find that one. And the laptop has tripped now. Okay. Let's put this kind of video. Experiment number 1, number 2, number 3, this, that. All right. In your tutorial sheet, question 8 in your tutorial sheet, you have this, you have initial rate, and you have these. So I believe you guys have this tutorial sheet. So tutorial sheet question 8 is just on the things we were doing today. So I want you to answer this particular question because it will be a revision of what you have actually done. So please answer question 8 for me. Okay, and this is very good. Write the rate law for the reaction. Explain your reasoning in arriving at your rate law. No calculations required. So meaning with this particular question, you are using my method to tell the answer. Thank you. So please solve that one. We meet tomorrow.
Okay.
All right.